How does Iran manage to produce ballistic missiles under international sanctions? What lies behind the veil of secrecy that shields its underground factories? Today we take you inside the dark and strategic world of Iranian military engineering, where technology, geopolitics, and stealth combine to create one of the most feared weapons of the 21st century. Get ready to learn how the missiles that have put the entire Middle East and the world on alert are built. To understand how Iran has built medium and long-range ballistic missiles, we first have to understand the international setting it operates in. For more than 3 decades, the country has been the target of a long list of sanctions imposed by powers like the United States, the European Union, and multilateral bodies such as the UN. These measures ban the import of key materials, advanced electronic components, specialized machinery, and dual-use technology, civilian tech that can also be used for military purposes. In that context, any country would see the development of a sophisticated arms industry blocked. But Iran chose another path. Instead of giving up or waiting for international cooperation, it decided to build its own technological ecosystem, designed from scratch and largely isolated from the rest of the world. What began as a survival strategy became state policy: develop national military technology at any cost. One of the first steps was to consolidate a secret defense program run largely by the Islamic Revolutionary Guard Corps and a network of local scientists and engineers. When importing parts was impossible, Iran poured money into research on composite materials, homegrown navigation systems, solid propellants, and alternative production methods. In parallel, it built a clandestine international network to acquire parts and know-how through foreign intermediaries, triangulated purchases, and gray markets. Allies like North Korea and Russia at times shared technology or advised. This isn't just resistance, it's strategy, and each missile symbolizes years of hidden engineering. Talking about missile manufacturing in Iran means entering one of the most hidden, tightly controlled defense systems. Many factories are buried under mountains and reinforced underground networks built to withstand direct airstrikes. They don't appear in public directories. Some surfaced only via satellite imagery and leaks. What is known remains fragmentary, but points to extreme secrecy. Inside these sites, the layout is built for survival and uninterrupted work. Tunnels link assembly, testing, and transport areas. High-strength steel and concrete allow entire missiles to be moved out of sight. The depth and design enable discretion and maintain production even under external threats. Security is layered: authorizations, biometrics, military checks. Transfers occur in closed vehicles, often at night. Many workers don't know their location. Crucially, these sites make not only missiles but also guidance, propellant, and airframe parts, cutting reliance on foreign suppliers. How many exist? Estimates suggest 10 plus, and uncertainty itself deters adversaries. Building a ballistic missile is not just joining metal parts with precise welding. It demands advanced materials that are extremely hard to obtain, especially for a country barred from buying sensitive tech and strategic supplies. So how do they do it? The key is local development combined with reverse engineering. Iran has replicated critical components by studying foreign missiles recovered from conflicts or testing sites, and by adapting commercial technology for military use. That requires high technical knowledge and a fully autonomous research network. In parallel, while some parts are produced domestically, others still arrive through foreign intermediaries, triangulated purchases, and gray markets with little traceability, sometimes with help from allies who share designs or advice during critical phases of development. Building a ballistic missile isn't just about fitting metal parts together with precise welding. It demands advanced materials that are extremely hard to obtain, especially for a country like Iran that faces sanctions blocking sensitive tech and strategic supplies. So how do they do it? The key is local development combined with reverse engineering. Iran has managed to replicate critical components by studying foreign missiles recovered from conflicts or tests, and by adapting commercial technology for military use. That requires high technical know-how and a fully autonomous military research network. One of the most complex elements is solid propellant. Unlike liquid fuels that need more delicate systems, solid fuel enables rapid activation and shortens response time. But making it means mastering precision chemistry. Ammonium nitrate, powdered aluminum, and special binders mixed in exact ratios to generate the right power without compromising stability. Another vital piece is the missile body. It must be light yet withstand temperatures above 1,000 degrees Celsius. So alloys of aluminum, titanium, and ceramic composites are used, often developed in metallurgical labs linked to the military sector. Guidance is even more critical. Iran relies on inertial navigation with gyroscopes, accelerometers, and specialized software. Systems designed to work without external signals that could be jammed. And while the world debates whether Iran has reached certain capabilities, the country has publicly demonstrated successful launches with missiles that travel more than 100 kilometers. Most likely, those missiles were built with a mix of technology developed domestically and foreign components adapted in secret. The big question that follows is, how many of these materials still manage to cross borders despite the blockades? Intelligence reports indicate that there are sophisticated smuggling routes, sometimes disguised as civilian exports, that allow key parts to enter the country. All of this happens in parallel with the growth of a national industry that depends less and less on the outside world. In this way, Iran has turned isolation into an opportunity. With patience, years of research, and shadowy strategic alliances, it has built a robust supply chain capable of producing missiles continuously without relying on the world's major suppliers. Once the materials are processed and the key parts fabricated, the most delicate phase begins: assembling the ballistic missile. This isn't linear or fast, it's a tightly controlled procedure where even a tiny error can cause a catastrophic failure or a deadly explosion. Work starts in intermediate assembly areas where engineers build each module separately: the propulsion system, structural body, warhead, guidance unit, and stabilizing fins. Then test them and finally join them to the main body. Iran favors solid fuel motors, less maintenance, longer storage, and shorter launch times. They're tested on special stands that simulate extreme pressures and temperatures near 1,500 degrees Celsius. Once validated, the motor connects to the central bay housing the inertial navigation platform, sensors that measure acceleration, orientation, and speed without external signals that could be jammed. Each system sits in reinforced, hermetically sealed capsules against vibration, humidity, and pressure changes. Verification is millimetric. 3D scanners, simulation software, even X-rays check joints and thermal coatings. After final calibration, missiles are stored in underground silos or hidden on mobile launchers and camouflaged rail platforms. Once a missile has been assembled, tested, and calibrated, it doesn't sit like a museum piece. Iran doesn't build missiles just to store them. The final phase is testing and launch. The most used test zones lie in southern deserts, including the provinces of Semnan and Kerman. Far from civilians and under tight military cover, the missile is moved at night along concealed routes. On site, it's placed on mobile launchers or temporary silos. Final electronic checks follow. Sensors are verified, the command center links in, and then the missile lifts off, climbing in seconds and, in some cases, reaching suborbital heights. Iran's ballistic launches aren't random drills. Each test is scheduled with political precision, often tied to symbolic dates, diplomatic tensions, or key negotiation moments. While Tehran says its tests are defensive, the message is unmistakable: we can strike if forced. After launch, the fall and trajectory are analyzed with drones, seismic sensors, and ground radar to measure accuracy, engine performance, and warhead effects. Then comes the media phase. Edited footage, dramatic music, and power graphics circulate on official channels and news outlets. Sometimes Iran launches multiple missiles from different regions to show it can hit many targets at once, while other tests remain entirely secret. At this point, the question isn't whether Iran can build ballistic missiles. It has shown launches, released images, and pushed forward despite isolation. The deeper question is why. Missiles are not just weapons. They're diplomatic leverage. For Iran, developing and displaying ballistic capability helps guarantee survival, regional influence, and strategic independence. The Iran-Iraq War in the 1980s imprinted a lesson: depending on foreign arms is a vulnerability. Today, missiles also strengthen Iran's bargaining power under sanctions and threats. Regionally, they project strength beyond its borders, support allies like Hezbollah in Lebanon or the Houthis in Yemen, and maintain a convenient tension. Ambiguity itself is a tool. If an adversary can't measure the exact threat, it must assume the worst, often as valuable as superiority. Iran keeps its ballistic program outside binding global commitments, arguing self-defense rights. Though it denies seeking nuclear weapons, some missiles are designed to be compatible with such payloads in the future. Meanwhile, research continues. Hypersonic claims, better precision, faster deployment, plus camouflage and mobility. The message: Iran doesn't want war, but it is ready to respond, and any attack would have a cost. The big unknown persists. If current conflicts escalate, how many more missiles could be launched, and what hidden capabilities remain? Which countries might copy this clandestine development model? Some watch with fear, others with respect. Tell me, is this about deterrence or preparation for an inevitable conflict? If you'd like to see more videos like this, please subscribe and turn on your notifications.